12.5 Recursive Rules. This finishes up Chapter 12 on sequence and series. Up until now, we've been defining all of our sequences. So we're talking about sequences only here, not sums. Sequences only. We've been doing what are called, what you've already been doing without even knowing it, is called, the word for it is called explicit. We've been writing explicit rules. So in the past, when you say a sub n equals, and you give a formula with n in it, that is an explicit rule where the term is based on the sequence number. Term is based on sequence number. For example, is it the first term, then it's based on 1. If it's the second term, it's based on the number 2. If it's the third term, it's based on the number 3, etc. So those are called explicit rules. But now we're going to do something that might seem even easier to some of you, and maybe it's just a different way of thinking about it. It's called a recursive rule, and that's where you define the term related to previous terms, which is super important when you write loops in computer science. Recursive rules, it actually makes writing algorithms and programming simpler to write it recursively. So recursive rules, the term is related to previous term, or terms. Previous, like the one before it or the one before that. And that's how you define it. It's called a recursive rule. So let's get into some examples then, and this will be like an objective, so I'll put a bullet for it because that's what, something on your test might ask you to do is so we'll start with write the first 4 terms, okay, given a recursive definition. So this is the easy direction. So we start with the easy direction. Number 1, let's say that you're told that a sub 1 is 3. You need to know where to start. So you have to be given the first term at least, and then you're given a sub n equals now this is where it gets a little different. A sub n minus 1 minus 7. That's a recursive definition. So let me tell you what this means. It's fairly simple. It means that the nth term is equal to the one previous minus 7. So the a sub n minus 1 means the one before a sub n. That's how you write the previous term. So all we have to do is expand this. It's easier than you might think. So a sub 1, well, it's given. A sub 1 equals 3. We know the first term. We need the first 4 terms. Now watch this. A sub 2, all you have to do is plug 2 in for n into the formula. So a sub 2 equals a sub 2 minus 1 minus the number 7. So that means, well, what is 2 minus 1? Okay, so that means a sub 1 take away 7. So do you see how it unfolds? And this is kind of how the computer unfolds it. So a sub 1 is 3 minus 7, which equals negative 4. So the next term is negative 4. And now, do you see, without going into plugging it in every time, the definition means that you're taking away 7. Of course it's negative 4, without doing all that work. You started with 3, you take away 7, you get negative 4. So you tell me what the next term is. Very good, negative 11. And then what's the next term? Negative 18. So those are that's expanding. And if you weren't sure, you could plug in a sub 3 into the formula. You would get a sub 2 minus 7, which means the previous term take away 7. So let's do another one. And by the way, what kind of a sequence is that right there? Is it arithmetic or geometric? Let's review. Arithmetic or geometric? Arithmetic is when you add a constant. Geometric is when you multiply by a constant. It is? Arithmetic, yes, good. Let's try this one. Number 2, let's say I tell you a sub 0 my first term could be a sub 0. That's fine. Equals 162. And a sub n equals 0.5 times 0.5 times a sub n minus 1. So this is a sub 0 is 162, and a sub n equals 0.5 times a sub n minus 1. That just means previous term. So let's see how that unfolds. Or you could just tell me what happens by looking at it. What do you think is going on? Times the previous term by 0.5. That's what it looks like. Let's actually plug in just a couple just to be sure. And then let's say, so then a sub 0 is given. A sub 1 equals 0.5 times a sub 0, right? If you plug in 1 in here, you get a sub 0. So a sub 1 is 0.5 times the previous, a sub 0. Half of 162 is 81. So we don't need to do any more writing out. We can just say the terms are 162, 81. You keep going. What's next? 40.5. Nice. And then 20 and a quarter. Good. Yes. Okay, so we're going to do one more, and then we'll go the other direction. So number 3, let's say a sub, this will look a little different, a sub 0 equals 1, and a sub n equals a sub n minus 1 plus n. That's our rule. So we know a sub 0, the first term is 1. And now let's plug in a sub 1 equals a sub 0 plus 1. Or I'm going to write it all out first. A sub 1 minus 1 plus 1. If you literally just plug in 1 in wherever you see an n, if you just plug in 1, it will be everything will be okay. So a sub 0 plus 1. So a sub 1 is, well, what is a sub 0? That's 1. It's over here. 1 plus 1, which is 2. So let's try a sub 2 equals a sub 2 minus 1 plus 2. Until you see the pattern, you just keep writing it out. A sub 1 plus 2, which is a sub 1. Well, let's look. What was a sub 1? Oh, that was 2. Plus 2 is 4. So we have 1, 2, 4. What's going on? Do you know what the next one is? Let's see. So we're doing the previous term plus n. So if we want a sub 3, the previous term is 4 plus 3, which is 7. So it's a really interesting pattern. Yeah? Previous term plus n. So the third term, a sub 3 equals, in words, sometimes it's helpful to write it out in words, equals previous term plus n. So equals previous term 4 plus n is 3, so that's 7 is how it unfolds. So let's see if we can get the last one. 1, 2, 4, 7. I guess we could stop there, but let's just be even better than that. Let's write the fifth term. So fifth term is previous term plus 5, which is? Previous term plus 5, which is 12, right? Good. Okay, hang on. No, 4, right? Yeah. Previous term, because this is a sub 0, 1, 2, 3, 4. This is a sub 4, would be previous term plus 4, which would be 11. Yes. Good. Very good. Okay. And if you're not sure, then go just plug it in explicitly.